Alright guys, so we've had some trouble with doing some trend lines and using linear regression. So this is a linear regression example for you. And in the table you see populations for New York City and LA. And this is from the US Census Bureau and it goes from 1950 to 2000. Okay, so here are the different populations for each city. And what they want to know are when will these regions have the same population? After how many years is this going to happen? So what we want to do is put this data into the stat feature, and we're going to have three lists, okay, L1, L2, and L3. And L1 is going to be years after 1950. Okay, so we're going to kind of make these numbers small, years after 1950. And we're going to do population here. So L2 is going to be the New York population, and we're going to really shorten these up. We're going to do, divide by 100,000 or so, and make these smaller. And so you'll see that in a minute. LA population. Okay, so we have these three variables that are going to go into our graphing calculator. So when I pull up the TID 4, and I've done a lot of this already to save some time. We're actually going to go to the stat feature there, stat, and you got to edit. So when I go to edit, I got to make sure, number one, everything's cleared out of here, and it is. And so what you're seeing and viewing here is look at L1, the years after 1950. So in 1950, it's 0 years after 1950. Here would be 1960, 70, 80, 90, and the year 2000. 2000 is 50 years past 1950. And here are the populations, and we shortened these up and divided it out, and went to the nearest tenth here and rounded because we want to make this smaller, so it's just easier to work with on the graphing calculator. So New York's population 12.9, 14.8. Okay, and that's going to be in millions. We just shortened that up, 16.1 million, right? 16.1. Okay, so look at these populations. That's where they're sitting here, and there's the LA populations. Now, if you want linear regression or linear equations, you go back to that stat feature, and what you have to do is go to Calc this time. And under Calc, you hit 4, the button 4, and that gives you your linear regression equation. So there's only a couple things you have to do. Now, I need two different equations. The years after 1950 and the New York population, and the years after 1950 and the LA population. So right now I have the years after 1950 and the LA population, but let's say I wanted L2 first. So I would go here and hit second L2, and that's my Y list, and I'm going to hit enter, and I'll go all the way down until it says calculate. This is the new operating system, so it might not look the same as your other calculator, the 84 plus, or if you have the old operating system. So notice here the first thing is my A value, that's my slope, and B is my y-intercept. So there's my first equation. Now I've got to go ahead and do this again for the population after 1950 in LA. So I'm going to go over to Calc, hit enter, and then what I'll do is go to number 4. Whoops, looks like I have to do that again, stat, over to Calc, and I hit 4. There we go, linear regression. And now I'm going to choose L3. Now, in a second here, you'll see some work up here. If you have the old operating system, you'd actually have to hit second 1, comma, second L2, or L3, so like second L3 here. And when you see the commas up here in the old operating system, you'd actually have to, it'll say linear regression, and then you'll have to put L1, comma, L2, and then close it off. You'll see it right, it's quick. So let me go down here and right there, that's how it would look, L1, L3. You might have to pause or go really slow to see it. Here's my other equation now. The slopes are different, that's good, so these lines will someday intersect. So I go ahead and I put each of those equations, one in for y1 and one in for y2. Now I'm going to adjust my window, and I'm going to go ahead and go window, and my max, this could take a while, so maybe let's go 100 years. Let's just see if we can go 100 years out. My Y minimum, let's just go 0. So my Y max is, I'm sorry, my Y max, or X max is 100, and let's go by 10. Let's go by 10 on the scale, and let's do, my Y minimum is 0 because we don't have negative years or population. I guess let's go to 100 here too and go by 10. Let's just keep it a square, okay? Alright, so let's go to, I like that. Let's go to the graph and see if these lines intersect. and they should intersect somewhere over here. Yeah, there we go. So, ooh, it looks like somewhere here. So we can actually find that. So that's 10, 20, 30, 40, 50, 60, 70, 80. Ooh, I would say just somewhere after 80 years is going to be where these populations are equal. So basically linear model, so if it would be 80 years past 1950, so we're looking at about 2030. Let's look at the intersect feature. So now if we go to Calc under second trace, we can go to the intersection. So that's number 5, intersect. So I'll hit 5. And I have to pick my first line, so I'm going to cursor over here. It says first curve. Let's go over here. So it's 50s. It's got to be somewhere in the 80s. So I'm looking at that X value here. Right about maybe there. It's got to be right there. So I'll hit enter. Now it's going to ask me second curve, and I'll hit right there too. And so they're going to ask me for a guess, and it's going to say, okay, so this intersection is 85.41 years. So basically what this is saying is that in the year, where's our button? There's active inspire. So the populations, so L2 will equal L3. Those populations will equal each other in about 2035. The year 2035, those populations will equal. And so the X is 85 years after 1950, so 2035 about, and then the population will be about 25 million. 25,300,000, 330,000, something like that. That's a rough estimate. So I hope that helps you guys calculate a linear regression. If you guys have any more questions or comments, let me know.